Boa noite. Tá todo mundo ouvindo aqui? Hugo,
Boa
um
noite,
minuto
Hugo.
antes atrasado. Não, estamos aqui.
Estou aguardando um time aqui.
Ô, louco.
Boa noite, Josimar. Galera. Ótimo, todos ouvindo bem.
Vamos lá. Ok, bem-vindos. Vocês hoje não escutam a voz do Marcelo porque ele está com problemas no áudio, mas está todo mundo aqui. Hoje teremos a apresentação live com o Nick e o James sobre Event Bridge. Ok? Todos conseguem nos escutar bem? Acho que sim. Boa noite. Então, vamos lá. Bom, a agenda de hoje é, primeiro, a mecânica, como funciona, o código de conduta que a gente costuma apresentar em todos os eventos, sobre o próximo encontro, os nossos agradecimentos, a apresentação e perguntas. Vamos lá. Vanessa, quer começar aí a mecânica?
Vamos lá. Então, pessoal, hoje temos 2 convidados aqui conosco. Vocês podem ficar à vontade para enviarem perguntas tanto para o James quanto para o Nick ao longo da apresentação deles. Se vocês preferirem, podem enviar as perguntas em português mesmo no chat, que a gente faz a tradução. A apresentação vai iniciar com o James, e aí, na sequência, o Nick vai concluir, ok? O James, ele se colocou à disposição para ir respondendo perguntas ao longo da apresentação, então não tem nenhum problema, mas a gente está acompanhando aqui o ritmo, vamos moderando para a gente conseguir ficar dentro de um tempo bacana, então enviem as perguntas que vamos nos certificar de que todas serão respondidas. O Augusto Sandoval está dizendo que enviou uma pergunta por e-mail já para nós. Vamos checar aqui e deixar... Ok, Augusto? Super rápido e eficiente. Obrigada aí pela colaboração. E como não podemos deixar de citar, faz parte da nossa atuação em comunidade, né, o código de conduta. Então, foi até um ponto bacana para esse evento online, que a gente viu uma oportunidade legal de atualizarmos o código de conduta, que fica lá disponível no GitHub para quem quiser colaborar, citando que o código de conduta descrito para eventos presenciais também valem aqui para esses eventos, esses encontros virtuais que estamos fazendo na plataforma, prezando sempre pela gentileza e pelo respeito com todas as pessoas que estão participando, ok? Reforçando, pode colaborar, né? Balancinho, quer comentar?
A gente deixa aberto para edição no GitHub, quem quiser entrar aqui nesse link e sugerir novas mecânicas para o nosso código de conduta. Se você viu que a gente tem alguma falha, você pode sempre mandar um pull request para cá.
Isso aí.
O nosso próximo evento...
Pode falar, desculpa.
O nosso próximo evento, no dia 26 de maio, juntamente com o grupo de AWS do Ceará. Quem quiser já entrar e pegar... Acho que já dá para inscrever, não sei se já está aberto. Tá, Vanessa?
Não está aberto ainda. A gente vai abrir na conclusão desse evento aqui de hoje, mas até aproveitando para perguntar, pessoal, digam aí de quais cidades, de quais estados vocês estão falando. Aqui é um reforço muito importante de que a comunidade ela vai além de fronteiras de cidades, de estados, né? Ainda mais nesse momento que a gente está, de distanciamento físico, mas a gente procura manter muito essa proximidade no contato com vocês, e como reflexo dessa proximidade, a gente vai ter uma conexão muito bacana aí com o time do User Group Ceara no dia 26 de maio, não percam. Olha a Luísa, de Brasília. Boa noite, Luísa. Cotia. Bacana.
Olha só, Dublin.
Verdade.
Quero agradecer quem não é de São Paulo participando.
Pessoal de Uberlândia, Vitória, Espírito Santo. Gente, a gente fica muito feliz aí de poder compartilhar.
O Hugo era de Cotia. Um agradecimento a quem possibilita isso acontecer todos os meses e eventos que realizamos eventos. A Web4, a Cloud8, a editora Nova Tech e a KDW.
Isso aí. Como não podemos deixar de agradecer, né, e citar, então, mais uma vez, Diogo colabora aqui conosco com um sorteio de um curso totalmente gratuito, que é um voucher para fazer um curso para certificação de Solutions Architect Associate. Para vocês que estão aqui nessa live com a gente, que tenham interesse em participar, por favor, façam a inscrição no link a seguir, disponível no QR Code ou no link a seguir, por favor, fala assim.
Opa.
Isso. Então, acessem a página web4.com.br/AWS User Group São Paulo e se inscrevam, que no final do meetup de hoje, o próprio Diogo vai entrar aqui, vai fazer o sorteio e vai anunciar a pessoa vencedora de hoje, ok?
Bom, e agora vamos começar com o Nick e o James para a apresentação sobre Eventbridge. Lembrando novamente, se tiverem perguntas, podem fazer em português mesmo, que a gente traduz no final.
Reforçando, é importante reforçar que nessa live a gente não vai ter tradução simultânea, mas vamos trabalhar para colocar a legenda no vídeo que vai ficar disponível depois no YouTube para que mais pessoas possam acessar e compartilhar e até assistir de novo, se for o caso, essa gravação aqui, ok?
Exatamente. Well, we can start, Nick and James.
Sure. Hello, everybody. Thanks very much for inviting us. It's really great to be able to talk to you. I'm James Beswick. I'm in the US on the East Coast, and I'm a senior developer advocate here at AWS Serverless. So I work for the Lambda team, and I think Eventbridge is one of the most exciting new products we have. So I'm really excited to be able to tell you about this evening. So, and we have Nick as well.
Hey folks, my name is Nick Smith. I'm based in Vancouver in Canada. I'm a product manager on Amazon Eventbridge. I'm originally from Cape Town in South Africa and really wish that I could be in person to give this talk in Brazil. We'll have to make sure James and I get down there next year. But yeah, really great to have the opportunity to talk to all of you tonight. So thanks for having us.
Great. Yeah, we'll definitely be there next year. But for tonight, we'll be talking about event-driven architectures with Amazon Eventbridge. So we're going to cover 3 different things this evening. First, I'm going to talk about some of the basics of event-driven architectures and some of the best practices for adopting this paradigm yourself. And then we'll provide an introduction into Amazon Eventbridge, which is a new serverless event bus. And then we'll take a look at how that service works and how it fits into some of the concepts of software development. Then we'll talk about some of the common use cases of Eventbridge. And finally, we'll show you some demos of how you can use this and what you can build with it. So let's get started. So I want to talk about a few of the challenges in software today. First, have you ever noticed how monoliths are just everywhere? We keep trying to break them down in software, and yet they keep reappearing. So you might have seen a slide like this before if you've seen any presentation from AWS. Now, this talk isn't about breaking down monoliths, but it's a big part of how Eventbridge can help us. So monoliths tend to get a bad rap. Often they're very easy for us to build as software developers, and they're easy to reason about and think about. Often you only have one ACID compliant database that's doing all the work. As you move towards microservices, distributed systems are just much more complicated to figure out and make them work. But the problem is that monoliths don't scale. They don't scale in terms of throughput or in terms of team size. So if you have a very large system with dozens or hundreds of engineers and you want to build features in parallel, you really end up having to move towards the microservices model. But even with that being the case, still monoliths keep showing up. Let me show you what I mean. So really the key goal here is to create customer value in what we're building as software developers and make sure that everything that we're doing leads towards greater reliability, greater resilience, and greater scalability. And of course, we have to do it faster all the time. So a lot of the time, the businesses that we're working for expect us to do more and more with the software. So all of these things we're trying to adopt and use, we really want to be able to build an environment where our software is helping us get more agile as we go. So let's talk a little bit about the challenges with building some of these types of distributed systems. The first thing to mention is coupling. So one of the big benefits that's often cited in microservices are decoupled or loosely coupled systems. But it's important to recognize that anytime you have two systems talking to each other, there's some degree of coupling that's happening there. And you need to understand the long-term ramifications for the health of your system. So in a really simple example, the synchronous API, and I'm sure we've all built plenty of these in our development lives. This is a fairly standard synchronous API. And when a client comes in and says, I want to make an order to the order service, the order sends a request to the invoice service, and then the invoice service does some work and it returns a response, a 201, saying it's completed the work, and then the order service returns that to the client. And that's it, and that's great. There's no monolith here. Clearly, we've got two separate services. And this actually works fine when you've got two systems like this. It's really pretty straightforward, and it's two separate systems. But what tends to happen is that as you add more services that integrate with your order service, it starts to get more complicated. The order service starts to have more responsibilities and becomes more complex. The order service must understand retry logic for each of these systems it's speaking to and has to build an SDK for each. And even if each downstream service publishes an API, then the team that manages the order service is responsible for talking to each of them. So any backwards incompatible changes in the API, and suddenly the order service team is on the hook to update these. And so long term, what happens is more and more systems out there need data from the order service. And in this model, those teams are blocked because the order service team has to implement changes to integrate with each one of these downstream services. And so they cannot operate independently as they once could. And so you have unnecessary friction in the process due to the integration cost of hooking these services together. And this slows down our development process. So the decoupling ends up being gone and the dependencies become more fragile. And really this starts to look more monolithic. Even though these are separate systems, they operate in a way like it's one big system. So what can we do about this? Here's a second issue. When you're trying to choreograph APIs, this is very difficult. And as APIs become more complicated into complete workflows, it can be very tough to make sure that each service has the right state. So here's an e-commerce application, and this has some additional downstream services. Now, in the happy path, everything works as expected. The order service is triggered, it calls the invoice service, that triggers a payment, and that triggers a forecasting service, which then causes fulfillment to activate, and finally that causes shipping. But what happens when something goes wrong? So if the fulfillment center realizes that they're out of stock, they physically don't have the product to ship, well, in this case, the fulfillment center may need to alert the invoice service, and then they have to reverse a payment or issue a refund or a credit. And then the shipping service may have already been triggered and started sending something. So that may need another message to fix that and send the payment back. And then also forecasting could be wrong as well, because maybe that service doesn't accept adjustments. So maybe the inventory is wrong and there has to be a manual adjustment. And all of this happens just because of one minor failure in the fulfillment system, that suddenly all of these different messages have to happen. Now, what happens if you add another service to this model? So this happens fairly typically in companies where, imagine your team works on a payment system, but you're not told when a reward service comes along. So what happens now when this reward service is integrated into this flow and the same error happens? Well, maybe the fulfillment system goes down and it orchestrates all of these other systems trying to send messages back to them to try and get them into a good state. But these other systems don't know about the reward service. So the reward service never finds out that there's a problem in this flow. And the result of all of this is that a customer gets rewarded for an order that ended up being cancelled. Here's another one when the reward service upgrades to a new vendor. Maybe they switch out a service with a different vendor and nobody else knows about this. So if there's a failure, does this new vendor know when there's a problem with this system? Here's one more issue for you. So let's talk about availability in these systems. So back to our ordering system where your team is managing these payments, there are a number of potential problems. The first is performance mismatch. It takes longer to process payments than to accept orders. So in very busy periods, your slower performance is holding up the order service and the customers are experiencing delays. And in synchronous APIs, typically putting a fast service in front of a slower service can cause a lot of problems. Also, there can be problems with outages. So if the payment service goes down, the order service also goes down. So the availability numbers for this total system is worse because these systems are so completely coupled. And if one fails, the other fails. At least that's the perspective from the end user. So how can events really help us with these three challenges? Well, firstly, what is an event? An event is simply a signal that the system state has changed. And often an event is represented as a JSON object, and it's some set of facts about the change that's happened, maybe some information about the new state and possibly the old state as well. And an event has certain attributes. Events are facts about the system. They're immutable. They cannot change. They're observable, and they're temporal. When they happen actually matters. So to help us to understand how these events are going to solve this, we also need to look at another important property of events, which is that they're asynchronous. So in a synchronous system, like on the left, when the client calls service A and calls service B, there's a lot of waiting in this system where the client is essentially blocked, waiting for service A to finish, which waits for service B to finish. In a synchronous model, there's no response path like that. As soon as the client calls service A immediately acknowledges the request back to the client, meaning the client can go on and do other things, while service A simultaneously talks to service B to get other things continuing to happen. Now, I said something earlier that is really important actually in this whole thing, which is events are observable, not directed. So what do I mean by that? Well, if you look at this traditional directed command model, what happens is the person on the left says to the person on the right, please create an invoice. And then the person on the right does that work and says, okay, here it is. In an observable model, it's slightly different. So in this case, in the observable case, the person on the left says, customer X just ordered a widget. Now, one person at the back hears this and decides to take action and add that to a sales report. Another person hears this and decides to send an invoice. And two other people hear this but decide to take no action. And there are several benefits to this. Event producers don't need to have any knowledge about who is listening to the event. They simply broadcast the fact that they have caused an event to happen. And this can keep them very simple. It allows other services around them, in this case people, to consume and listen to those events without needing any sort of upstream changes. So it's really interesting with people, but how do we implement that in a real system? So if we go back to our order service example, how do we pass information from this order service to all these downstream systems without calling them directly? Well, for that, what we need is an event bus. So this provides an endpoint where an event producer can send events, and the router manages directing and filtering those events to the appropriate downstream consumers. Consumers then can get the events that they care about while the producers remain completely decoupled. So now when we put the event bus in the middle here, our architecture looks like this. The order service sends events to the bus, which is then configured with rules. And the rules determine which downstream systems get the event. So some of those targets only care about certain events, whereas other of the targets want to receive all of the events. But either way, the router takes on the complexity of making sure that the events are propagated to the right party. So if you go back to our example from earlier, if we introduce the event bus here, it looks fairly similar, but there's a couple of differences. So now you have the event bus in the middle. Now, if the fulfillment service has an error, like we showed earlier, all it needs to do is send an error event back to the event bus. And anybody who's interested in listening to that error event will receive that event and can take action accordingly. So then in the other problem we talked about with having a new service, the reward service added to the architecture, this is much easier for them too. So the reward service can simply consume an event from the bus. They don't need to tell the order service team. They don't need to integrate with any other teams either. They can simply decide to add their service. So now these service teams that consume these events can act independently, and they can make software more quickly. So this is interesting because it basically means your services can produce and consume messages off of the event bus, but they don't need to know about each other. Each one of these boxes represents a service that's completely independent. So as your applications start to expand and include other systems beyond your immediate control, you need to pass information to and from those services. Now, this can be difficult getting data from other systems because you don't own the code. So how can you get that sort of information? You have a few traditional options. The first one is polling. So in the case of polling, if your third-party provider has an API, you can ping that API every so often to find out if there's new information available. Now for this, you might do something like build a Lambda function that can poll for new information from that API. And polling is something we've used for a very long time in computer systems, but it's really a last resort option because it creates a lot of load on the SaaS provider, and many of the polling requests return with no information. Most of the time, information is not changing. There's also a lag between information becoming available in the SaaS provider and becoming available to the poller caused by the frequency of the polling. The second option here are webhooks. Now, webhooks are a much better option for the most part, but your SaaS provider has to have integration for this. Now, in this case, you would create an HTTP endpoint, maybe with API gateway, and maybe you'd use an authorizer so that you have some sort of token that you pass between the two parties. Now, the data when you do this is actually much closer to real time, but it's infrastructure that you have to manage. You have to build the webhook, and it's something else you have to integrate with your own service. So when you look at webhooks, they are simpler than post and get, and that's definitely better than using polling. And you do get this near real-time effect. But one of the downsides is that if your service goes down for some reason, your SaaS provider may not realize this, and you may lose information. They may not try your endpoint over and over. Also, a webhook is a public HTTP endpoint. So this means your traffic is going over the public internet. So it's not as secure as it could be. And it can be very difficult to scale. If you have a provider that creates lots and lots of events and has lots of information, they can send all of this your way. And you have to basically scale your infrastructure on demand to be able to meet that kind of load. So can we do better than webhooks? Well, we can, because we've got a new service with AWS that is a serverless event bus called EventBridge. So this was announced last year at the AWS Summit in New York. It's a serverless event bus service, meaning that there's no servers that you need to manage. And it finally makes events first-class citizens within the AWS system. So EventBridge can help you ingest and route events from SaaS applications, AWS services, and your own systems. So it evolved from CloudWatch events, which is a service that's been around for quite a long time. So it's not completely brand new, but it has new functionality that CloudWatch events doesn't have. And it's already processing trillions of events every month. So I mentioned it was a serverless event bus. So let me just mention a few things about serverless, because often this is new to people. So in the case of serverless applications, this is a set of services where there's no infrastructure for you to manage and there's nothing for you to provision. So in the case of AWS, these are services like S3, or DynamoDB or Lambda. You can choose to use these services, and how they work in the background and how they scale to meet your demands is completely managed for you. Also, typically with serverless systems, you pay for what you use, you pay for value. So if you have a Lambda function that you don't call very often, then it doesn't basically cost you very much. Whereas typically a server-based infrastructure, you're paying for an instance, a virtual instance, or a server that you may or may not use. And also with serverless systems, these tend to be very highly available. They're built to withstand massive load, so they can scale very easily to meet your needs. And they're also very secure. If you look at everything within AWS, security is job number one for us. So everything we design is designed to be as secure as possible. So if you look at how serverless fits into the broad scheme of things, because it is a fairly new phrase to people, serverless functions as a service, or FaaS as it's shortened to. This is Lambda within AWS. This is where you put your custom code that you want to run on demand. And typically that unit of code would be a function. In the broader scheme of things, this is functions as a service, and it fits into this idea called event-driven computing, which simply means that when your code doesn't run unless there is an event that causes it to run. So an event could be something like an object being stored in S3 or an HTTP request. So with Lambda set up this way, it means you can run code for virtually any type of application or backend service, all with zero administration from your side. All you have to do is upload the code, and Lambda takes care of everything needed to scale it up on demand. Now, within the AWS space, there are all sorts of different event sources you can use for your Lambda functions. And Lambda doesn't sit in a vacuum. It has to integrate with these other services to have a working application. So when you look at an event source, this could be something like a change in data state in your DynamoDB table, or requests to endpoints like API gateway, or changes in resource state. And all of these, when these happen, can be connected to trigger a Lambda function. Now, the Lambda function itself supports all sorts of different runtimes. So it supports Node.js, Python, Java, Go, Ruby, and there are all sorts of other runtimes too. You can build your own. So we have people running Erlang, COBOL, PHP, and all sorts of other runtimes. So Lambda really is an execution environment for your code, and it doesn't really care which runtime that you run, so you get to choose the one that you prefer. And if you only need one runtime per function as well, so it's possible to have applications that have lots of functions, all with different runtimes, if that's what you need to do. And each one of these Lambda functions can trigger anything within the AWS ecosystem, but also it can reach out to anything beyond as well. So if you want to use payment systems like Stripe, or authorization systems like Auth0, you can do all of that from your Lambda function. And then very quickly, I just wanted to mention a few things here, because this is very important when you build Lambda-based applications. There are three types of model we use. So in the synchronous model, this is the one that you most typically see with API Gateway. When a request comes into API Gateway, it turns around and calls a Lambda function. And API Gateway waits for the response. The return value of the Lambda function goes back through API Gateway back to the caller. In the case of the asynchronous event, this is triggered by services like SNS or S3, the storage solution we have. And when that happens, those cause events that are put into an internal queue. And Lambda fetches those events from the queue, and it processes them asynchronously. And the biggest difference here is that you cannot return values back to the caller. So SNS and S3 don't get to receive the return value from the Lambda function. And then there are stream-based or polling-based events from services like DynamoDB, our NoSQL database, and Kinesis. So in the case of these receive very large numbers of events, and these are put onto queues or streams, which then are processed by the Lambda service. So there are these three different models, and you can pick and choose depending on how you structure your architecture to find the best model that works for your application. So with that, I'm going to turn it over to Nick now. I'll just stop sharing my screen, and he's going to show you a little bit more about EventBridge and walk us through some of the examples that we have for you.
Thanks so much, James. I'm going to just go full screen on my PowerPoint, and as I'm only on a single screen, James, maybe you can just let me know that you can see this okay.
Yep, that looks good to me.
Cool. So James has given a great overview of event-driven architectures and serverless and when you might want to use those in building your applications. What I'm now going to do is dig into a little bit more detail about how EventBridge itself actually works, how it's different to other AWS services like SNS, or MQ, or Kinesis. And then we'll look at some examples of how you can actually use EventBridge to and write code that uses EventBridge. So as James mentioned, EventBridge is fully serverless, so you don't have to scale it up or down. We take care of all of the scaling for you, and you only pay for what you use. EventBridge is integrated with a range of different services, so you can receive events from a wide variety of sources. And we charge $1 per million events ingested into EventBridge. There's also no additional cost for sending events to a particular target, so you only pay for receiving those events. Let's take a look at the architecture of the EventBridge, or the different components that you can use. Starting on the left-hand side, we have 3 different sources of events. The first is AWS services. And as James mentioned earlier, if you're familiar with CloudWatch events, you might be used to being able to use your default event bus in CloudWatch events and within EventBridge to monitor AWS services that are generating events. An example of this might be an EC2 instance that starts up or shuts down, or an object getting written to S3. All of these can generate events into your default event bus that you can then use EventBridge to react to. We also have custom events that you can send from your own applications. So you saw James's example earlier of an e-commerce example where we received orders and those were sent to an invoicing system. So EventBridge is a great way to connect up events from all of those different microservices. And then finally, we have integrations with various SaaS providers. Today, we support around 26 SaaS providers, including SaaS companies like Zendesk, Datadog. There's a whole lot more coming soon as well. So with that particular use case, if you're receiving events from these third parties, we allow you to create what's called an event source. And this is actually created by the partner in their AWS account. And so for example, Zendesk, if you're wanting to receive events from them, they would create a partner event source, which is created in Zendesk's account and then made visible to your AWS account. You can then associate that event source with an event bus in your account. And when you do that, events will start flowing through from Zendesk's partner event source to your event bus. The next part of EventBridge is the event bus itself. And this is really the kind of core part of EventBridge. All of your events that are sent, whether it's from AWS services, from your own applications, or from a SaaS partner, funnel into an event bus. And you can use event buses to set permissions on who can publish to a bus. But typically, the architecture that we see customers using is a single event bus across their entire organization, to which they publish all of their events. And the great thing about this is that it's really easy to then find events that are being published by your different applications. If you've used SNS in the past, you might find that often you have to create multiple topics so that you can filter out which events each subscriber is getting. With EventBridge, we typically see customers having a single event bus instead of multiple SNS topics. And this has a lot of benefits in simplifying their architecture. The reason that you can have a single event bus in EventBridge is because of rules. And rules are really the powerful part of EventBridge that allow you to route events to different targets. Rules can apply to the full payload of an event. So you're not just able to filter on the attributes of that event, but actually any field or value within that particular event. To understand how rules work, let's take a look at a quick example. On the left-hand side here, I've got an event. It's got a detail type of ticket created. It comes from a particular partner in the source field, and then it's got a payload in the details section. So we've got a ticket ID, a department, and then a creator of the particular support ticket. So if we want to create a rule that routes this particular ticket, we could generate one on the right-hand side. You can see over here, this rule is simply saying we're looking for a source where that is set to this value of AWS partner /examples.com/123. So because this event on the left-hand side that comes into the event bus has that particular source, it will match against this rule in our account and trigger this rule. We can get a little bit more advanced in our rule and say that we're actually looking for any events where the department is either the billing department or the fulfillment department. So because you can see this event has a value of billing for the department, it will trigger against this rule. And here's an example of a rule that won't match against this particular event. So this is a detailed type of ticket resolve that we're looking for in the rule. And because this is a ticket created event, it won't match against this rule. So you can see rules are expressed using JSON, and there's a range of different content filters that we can use in our rules. I demonstrated some of the easier, simpler ones here where it's an exact match, or we could look for empty fields. We can use and or operators. So we could look for a payment type of credit card or debit card, but we can also get a lot more advanced in rules. So here are some examples, for example, here using the anything but content filter. So we could say we're looking for a weather field that has any value except raining. We can look at a price that has a numeric value between 10 or 20, or a product name that either exists or doesn't exist. So if that field isn't present, we can trigger the rule. We can also do suffix matching. So prefix matching. So here we are looking at a region that starts with AP dash. So these rules are really powerful in allowing you to select a very specific set of events that you want to route to a particular target. And again, these aren't just available to match against the attributes of an event, but actually any content within the payload of the event itself. And so going back to that comparison with SNS, we find sometimes with things like SNS, you run out of attributes to be able to match against. And so you have to create additional topics and then have subscribers figure out which topics they subscribe to. And so in those situations where you expect to have quite a few subscribers, EventBridge allows you to centralize the sending of those events to a single event bus, and then have any subscriber come and add a rule on that bus to route the event to a particular endpoint that they're using. So once you have rules that match against an event, each rule has a target and up to 5 targets that you can send an event. We support a range of AWS services as targets. For example, AWS Lambda, step functions, Kinesis, SQS, SNS. There's a range of about 18 different AWS services that we support, and we're adding to this all the time. So with these targets, EventBridge takes care of sending the event to that particular resource or AWS service. And this is different again from something like Kinesis or Kafka or SQS, where you're responsible for polling that particular queue or topic or stream, and then pulling events or messages off of that particular stream or topic. And so with EventBridge, you don't have to worry about any of that boilerplate code to pull off of the topic or stream. You don't have to have any infrastructure that does that. EventBridge will take care of delivering the message to a particular target. If for some reason that target is down, we retry delivery for 24 hours with exponential backoff. So you can be really assured that when an event comes into EventBridge, we'll make sure that we deliver that to the specific target. Okay, so we've taken a quick look at how EventBridge itself works, but let's take a look at how you might use it in your code. I'm going to start or go back to that example that James showed us earlier with an order service that's sending a request to an invoice service. So here, if we were to insert EventBridge into the middle of that, the order service would publish an event to the event bus, and then the event bus would use a rule to route that to the invoice service. So taking a look at the code for this, we might have a Lambda function that is receiving new order requests potentially from an API endpoint. And out of that request, it generates an order event. So we can see here in this example, we set some JSON values, the state created, the order ID, we generate that. We give the event a detail type. We specify which event bus we want to send it to, and we specify the source of this event. We then also set a timestamp for this. But you can imagine a real life order might have a whole lot more detail, like what product was ordered, what the price was, and various other information. We can then call the put events API and specify the payload that we described earlier up. So what happens is when this Lambda function runs, it will send an event to EventBridge, to the event bus that we specified. And we can then have a rule on that event bus that routes the event to a Lambda function that will generate an invoice for it. So here you can see this Lambda function runs. It receives this, it's triggered with this event that gets sent to the Lambda function as an argument. And we can then use that event in our code. And that event simply reflects whatever was sent from this order service publisher over here. So taking a quick look at the rule that would route this, we can see a CloudFormation template here that simply says we have an event rule and we have a source of demo.orders, a detail type, a detail section with a state that is created, and the state of this rule is enabled. So really simply in a couple of lines, we can describe the rule that will trigger this particular event to be sent to the invoice service. And we can set the invoice service, this Lambda function over here, as a target of that rule. So you can see over here in the section at the bottom, we're saying that the invoice service function is set up as the target. So it's as simple as that, to have an order service that publishes this event, sends it to an event bus, having a rule that then will route that event bus to a particular Lambda function that will deal with that event and generate the invoice. And you'll notice that our two services are totally decoupled here. So the invoice service doesn't need to know anything about this order service other than the fact that it's sending one of these events. And the order service has no idea that the invoice service is actually using that event. So if there's any problem with the invoice service, it doesn't impact the order service. And you can scale those two individual functions separately. Let's also take a look at what happens when that reward service comes along. So say our company decides, well, along with invoicing, we now want to actually have some rewards program that we offer our customers when they place orders. Well, it becomes really easy to add the reward service as a subscriber to those events from the order service. You can see here that we've just added a new rule that adds the reward service as a target for this particular rule. And so any events that come in now that have this new order created, pattern will match against this rule and go to the reward service. We didn't have to do any more API integrations from our order service. It was just as simple as adding that rule to the event bus. So you've got a whole lot of events now that are getting published by a range of different publishers. Potentially you have an order service that's sending events. You might have a downstream invoicing service that generates an event once the invoice has been created. And we find that a lot of organizations very quickly land up with loads of different events, and it can become quite difficult to track down those events and figure out what they actually look like. And so we've developed the EventBridge schema registry that allows you to store all of the schemas for the events that you're using and quickly and easily search those. So what is a schema? A schema is simply a description of the structure of your events. So in our example earlier, we saw that we had an order event that might contain a user that created it, potentially a price, and a product. And each of those fields in that event describe the structure, and each of those fields have a type. They could be a number, a string, a Boolean, and all of that is really important to us as developers to know what those fields look like and what kind of value we can expect in them, and what actual values are available in the event itself. So the schema registry allows you to very easily search for any events that you're using, or schemas of the events that you're using in your organization. And then you can download code bindings for each of those schemas. So we've realized that if you have an event, you want to be able to get working with it in your code very easily. And so what the code bindings do is generate a class file that you can import into your function or code that you're writing. And then you have the strongly typed object that represents your event. So it makes it really easy to get up and running and responding to events. We've also developed a feature called schema discovery. Schema discovery allows you, can be enabled on an event bus. So you turn it on your event bus that you're using. And EventBridge will automatically scan all of the events flowing through that event bus and then generate schemas for them in the schema registry. So you don't have to manually go through each of your events and figure out what the schema is and manually write the schema. You simply emit your events to the event bus, turn on schema discovery, and we will automatically populate the schema registry with all of the events, with the structure of the events that you're using. So let's take a quick look at the schema registry and how we can use that to quickly respond to events. I'm going to switch to PyCharm, which I'm using to build serverless applications. And I'm going to go ahead and create a new project. When I do this, I can select a AWS serverless application. And from that, I can choose the EventBridge app from start. So what this is going to do in the background is use a tool called SAM CLI, which allows us to generate serverless applications using this CLI tool. But what I'm going to do is I'm going to go and specify that I actually want this serverless application to be generated using the schema in my schema registry as a trigger. So you can see I've got a load of different schemas in my registry. We've got a whole lot of AWS events that emit that can be sent through your default event bus, and we've got schemas for those in the registry. But I'm going to go ahead and choose this. Where was it? My ATM example. So I've got an ATM transaction that occurs, and so I want to write code that reacts to this particular event. So I can choose that event and then hit the create button. And what will happen in the background here is that the SAM CLI will start generating a serverless application in Python, because I've specified that I'm using Python here. It'll generate that Lambda function, and then it'll go and create the actual code bindings for that particular schema file and create those as class files in my code project. So let's give it a few seconds just to finish processing. Cool. So SAM has finished generating my serverless application. I can then go into my tree structure here and have a look at my function that is being created. And you'll notice that I have two folders here. The one is the Hello World folder, which contains my actual function that will get run. And then I have another folder here called schema, which inside of that contains the actual class files that represent the schema for my event. So if I go into this transaction model over here, you can see that we've actually got a class file that describes the structure of the event that will come through. So there's some attributes like an action, an amount, a card present, whether there was a card present in this transaction, the location of the ATM transaction, and how many funds are remaining in my account. So if I then go into my app.py, so this is where I would actually write the code for my function, you can see, if you're familiar with Lambda, I have a Lambda handler here that is invoked when my Lambda function runs, and an event that is passed to that Lambda function, which in this case is my ATM transaction. But what we now have, which is a bit new when we're using SAM, is this example, this code that's been added here, which takes this event that is invoked by when the function is invoked and marshals it into a detail variable and into that transaction model that I've described above. So what I have is the ability to then type something like detail dot, and PyCharm uses autocomplete to be able to go and actually determine what fields are available based on the schema of that event. So we saw that we had remaining funds and an amount, whether a card was present. All of that is available to me as part of the autocomplete in my IDE. So what we've gone from here is the knowledge that there is some event being sent to an event bus that we've generated a schema for into our schema registry. And so without having to go and search for that or go and figure out what fields are available, I've simply created a Lambda function, specified that I want to use that particular schema as the trigger for the function. And now I have this object in my code that represents the event that I'm using, as well as all of the autocomplete and strongly typed functionality that comes with that. You can also see if I go to the template.yaml file, which is used to provision resources when I'm deploying my serverless application, we've gone ahead and automatically created a CloudWatch event or an event bridge rule for this that will invoke this particular function. So you can see here, this is my hello world function that we've created. It's a serverless function. It's written in Python. But then I have this event bridge rule that is created. I specify the event bus. So potentially I have an event bus called ATM that I want this rule to be created on. And then we can specify the pattern that we're wanting of events that we're wanting to match against. So I know that the source and the detail type for this particular event is custom.myATMApp, and the detail type is transaction. So this will create a rule on EventBridge with a pattern, a JSON pattern that matches against these two fields, and then invokes my function that I've defined here. So what I can very easily do now is go back to my app, go and write some code that responds to that function in some way. Potentially it needs to send me an email or push notification to say that withdrawal has happened on my account. Once I finish writing that code, I can simply deploy the serverless function right here from my IDE by right-clicking on it and saying deploy serverless application. So when I do that, it'll go and create that Lambda function, set up all of the permissions, and then create the rule on the EventBridge event bus that will invoke the Lambda function. So really easy way to get up and running when you're using schemas. I'll go back just to our presentation just to look at a couple of other use cases, and then we'll step into a quick example of how you can use our SaaS integrations with EventBridge. So some of the things that we see customers doing with EventBridge is taking action based on some sort of event that comes from an AWS service. So you might, for example, have an object written to S3, potentially a customer of yours uploads a file or a document or an image, and you want to do some analysis of that particular event. So with EventBridge, you can very easily pick up that S3 object being written, send that to a Lambda function, which will then take some sort of action. Potentially it might generate a thumbnail for that image or use one of our AI services to analyze it. You can also run workflows. So a lot of customers use step functions with events being sent to EventBridge. And this allows you to orchestrate a number of different actions that need to be taken when an event happens. So for an example, you might have a new user created in one of your applications. And when that happens, you might have to take multiple steps. For example, creating an account for them, setting up some billing information, and all of that can be orchestrated through step functions. It's also really easy to apply intelligence based on events. For example, and I'll dig into this a little bit more just now, but you might receive an event from Zendesk that a new support ticket has been created. You can then use Amazon Comprehend or Amazon SageMaker to do something like sentiment analysis or some sort of machine learning on that ticket, and then change the priority of the ticket based on the sentiment or some sort of machine learning that you're doing on that ticket. We also have a lot of customers that will do auditing and analysis of events. So you might have a situation where customers are clicking around your website, generating clickstream data. It's really easy to set up Amazon Kinesis Firehose as a target of an EventBridge rule and send those events to Firehose, which will then store them in S3. And then you can use something like Athena to run queries on all of those events. Lastly, we see customers doing a lot of synchronization of data. So you might have some event that gets triggered in Datadog, and you want to store that in DynamoDB. Or potentially you have something that happens in Zendesk, and you want that to go and send an event to PagerDuty, for example. So there's a lot of ways to use EventBridge to keep your data in sync between different applications. I'm going to hop over now to show you one of those examples that I talked about, being able to use Zendesk with Amazon EventBridge. So if I go into Amazon EventBridge, you'll see on the left-hand side, I've got my navigation. This is the EventBridge console. I've got in my navigation a couple of those concepts that we talked about earlier, event buses, rules, and then partner event sources. So in this case, I'm wanting to receive events from Zendesk. And when a new ticket is created in my Zendesk platform, For those that don't know, Zendesk allows you to create support tickets. So potentially a customer is having a problem on your website and they use Zendesk to create a ticket. You could then have those new ticket created events come into EventBridge and route them to something like Lambda or any of the targets that EventBridge supports to do something interesting with those events. In this case, I'd really like to use Amazon Comprehend, which is one of Amazon's machine learning and AI tools that can do sentiment analysis. So I want to figure out, does this ticket have negative sentiment? Is someone really unhappy with my service? And if so, I want to increase the support or the priority rating for that ticket so that our support agents can see it's a really high priority ticket. So in the EventBridge partner event sources, I can go into my Zendesk partner event source. There's some more details about how the integration works and some of the use cases, but I'm going to go ahead and click the setup button. What I can then do is copy my AWS account ID and head over to Zendesk to start the integration. I've opened this up in another tab, so I'll just go into my Zendesk admin console. And you can see here, Zendesk have this place for me to manage my integration with EventBridge. So I'll click connect on that and then paste in my AWS account ID that I copied from the previous step. I'm then going to specify which region I'm using this in. So I'm in US East in North Virginia, and I'll choose the type of events that I want Zendesk to send me. In this case, I'm just going to select all of the events so that I get everything from Zendesk. I then just accept the terms and conditions. So what I'll do now is click the connect button. And in the background, what happens is Zendesk go out and create what we call a partner event source. So what we don't want to have here is some sort of situation where you have to give Zendesk a whole lot of permissions to create resources in your AWS account or send data to your AWS account. So instead, what Zendesk is doing is creating an event source that sits in their account, but is made visible to your AWS account. So if I go back to EventBridge, to my partner event sources, what I now have is an event source from Zendesk that is in the pending state. So at this point, any events that Zendesk send to me don't actually, or to this event source, don't actually come through to my account. To be able to receive those events, I have to select that event source and associate it with an event bus. And so when I do that, we create an event bus, which is now linked to this Zendesk event source and starts receiving events from it. So if I go into my event buses, and apologies, I've got a whole bunch of them for testing purposes, but you can see if I go back here, I have a new Zendesk event source, sorry, event bus. You can also see that I can turn on schema discovery for that event bus, which I mentioned earlier. And if I do that, we'll start discovering the schemas for any events that are sent from EventBridge, from Zendesk. I can then create rules on top of that bus. So if I go into my rules section and I search for my Zendesk event bus, you'll see that I've got a rule for the schema discovery, which sends that event to schema discovery, but I don't have any other rules on my Zendesk event bus. So what I want to do now is start matching against my new ticket created events and send them to a Lambda function that'll do the sentiment analysis on them and update my Zendesk ticket if it finds that there's negative sentiment. So I'll go ahead and create a rule. I'm going to simply call this my sentiment analysis rule. I'll leave out the description, and then I'll fill in my rule pattern. So as we saw earlier, this is just a JSON pattern that explains the types of events that I want to match against. So I could get really advanced here and go and say, well, I'm looking for a very specific event, Zendesk type of event. But in this case, I'm just going to send all of these events to the Lambda function. And then at a later stage, I'll come back and I'll edit my rule to make sure it's only sending the specific events that I want. I'll then make sure the rule is getting created on my Zendesk event bus. And I'll choose the Lambda function or target that I want to send this event to. So you can see, as we talked about earlier, we support a range of different AWS services as targets, everything from SNS to SQS to Kinesis. But in this case, I'm just going to choose my Lambda function. And I've already created a Lambda function that will do that sentiment analysis. I've just called that function Zendesk Ruby because I wrote it in Ruby. So I'll go ahead and create that rule. And you can see that rule is now enabled on my event bus. Let's hop over quickly to my Lambda function just to see what I'm doing there. It's a really simple function. It starts off and receives that event from Zendesk. It then checks if it's a support ticket comment created, and then maps out the various fields in that event to a particular variable. We then call Amazon comprehend, and we ask comprehend to detect the sentiment and pass it the comment from that particular ticket that was created. If the content or the sentiment for that comment is negative, we then update our Zendesk ticket and assign it a priority rating of urgent, and we add some tags to say that a manager is required and that it should get priority support. So you can see below that, I've just got a function that'll make an API call to Zendesk to update the Zendesk ticket. Okay, so I've created my rule. I've hooked that up to my Lambda function. What I'm now going to do is go into Zendesk and create a support ticket. So I'll come in here. I'll give my support ticket a subject, my really bad support ticket. And I'm going to make sure that that Amazon comprehend picks this up as a negative ticket. So I'll say, I'm really disappointed in your service. This is very bad. And I'll submit that as a new ticket. So what you'll see is this ticket gets created in Zendesk. And if we look over here, it's got no priority rating assigned to it yet. But if I refresh this particular view, you can see the priority is being set to urgent. And if I go into that ticket, you can see that these tags of manager required and priority supports have been added. So it happened really quickly, but what went on in the background here is as soon as we created that Zendesk ticket, and again, this might be something that happens on your website from a customer or perhaps automatically generated when they email in. But when that ticket is created, Zendesk sends an event to EventBridge. That event matches against the rule that we created and then is sent to our Lambda function. The Lambda function then uses Amazon comprehend to detect the sentiment of the ticket. It found that there was a negative sentiment, and so it did an API call to Zendesk to update the priority and the tags for that particular ticket. So a very quick and easy example of how you can use EventBridge to receive events from a third-party SaaS application, and then very easily respond or react to those particular events. Cool. So we ran through a couple of examples there on Zendesk. I'll hop ahead just to the conclusion here, just to say that the really important takeaways with event-driven architectures and EventBridge is that they allow you to decouple your applications. So you're not having an invoicing service, for example, or an ordering service that's reliant on an invoicing service. Those are totally decoupled applications. And that makes your applications a lot more resilient and reliable, and it makes them a lot easier to scale. EventBridge also massively simplifies routing. Instead of having lots of topics where you have to figure out where events are being sent, you just know that they're being sent to your event bus, and you can use the schema registry to find out what those events look like. Event-driven architectures also really improve the availability of your applications. One part of your microservice going down will not affect your other part of your microservices because they're totally decoupled. And EventBridge also makes it very easy to integrate with third parties like Zendesk. There's no need for you to set up polling infrastructure or webhooks to receive events from those particular providers. EventBridge takes care of receiving all of those events and routing them to whichever application you're using to react to them. Cool. So that is James and my presentation. We're really excited to answer any questions that you might have.
Yeah, and I was just scrolling down through the list of questions, which we can take those, Nick. I was going to go from oldest to newest.
Cool. So let me just catch up here.
Yep.
You said oldest to newest or newest to oldest, James?
Yeah, I was starting at the top and scrolling down.
Okay. Do you want to take the first one and then I'll catch up?
Sure. So do you think this is a good opportunity to review workloads and adopt serverless and event-driven architectures? Well, I do, because one of the things is that serverless architectures can become fairly large fairly quickly. And so EventBridge gives you a really good way to decouple those and build smaller applications that are easier to manage. So I think if you haven't yet started building serverless applications, EventBridge gives you a great opportunity to start embracing this and finding ways to migrate your workloads into this environment.
Cool. I think there's another question here about, is there online training for EventBridge?
Sorry, there's some feedback there. Say again.
Vanessa, I think you might need to mute on your end.
Okay.
Thanks. So James, the question was whether there's online training for EventBridge.
Yes, so we have a learning path on the AWS site that collects together a lot of different resources, blog articles, videos, and other things you can do. It takes about 60 minutes to 2 hours of your time. And we're going to post that link into the description of this video after the talk. Also, I have a playlist on YouTube of 7 different videos with EventBridge showing you how you can set it up and how you can make it work with different SaaS providers. So we have lots of different materials available for you to learn how to use this.
Cool. I see there's another question about how is this integrated with IAM? So IAM is used for AWS to control permissions, and EventBridge is deeply integrated with IAM. So there's a couple of different ways that you can use IAM to set permissions for EventBridge. I think the one that's really interesting is being able to set permissions on the types of rules that can be created on an event bus. So you might have a situation, we gave that example of connecting up the invoicing service to the order service. Potentially you have a forecasting service and various other services that are consuming those order events. And you might find that actually the order events have some sensitive information in them that you don't want to make accessible to everyone. So you can use IAM to control the types of rules that a particular account or IAM user can create on an event bus. So you might, for example, limit the types of rules to say your forecasting service can't get events related to customer data. They can only create rules where the source is new orders and the detail type is order created. And that'll mean that that particular account or IAM user can't go and create a rule, for example, about user information. You can also use IAM to control put events, which is the API to send events to EventBridge. So that allows you to configure who can publish to your event bus. I will say that we're also doing a lot of work to work on resource policies for EventBridge. So you'll be able to fairly soon set all of this on a resource policy for an event bus. So if you have more specific questions about permissions, please feel free to send them to me. There's a whole lot that you can control on EventBridge related to permissions. I see there's also a question about the integration between EventBridge and CloudWatch, and I assume this is using CloudWatch metrics because you're looking for KPIs on events and rules. And so there's a bunch of metrics that we emit to CloudWatch. So you can go and see, for example, things like whether an event is matching against a rule, how many matches against a rule took place, how many invocations of a particular target took place, and then you can also see failures. So if we weren't able to deliver an event to a particular target, that will show up in CloudWatch metrics as a failed invocation. So if you go into EventBridge and you generate a couple of events and create some rules and then head into CloudWatch metrics, you should see all of those metrics available in CloudWatch.
Yeah.
Another question on how long it takes for a rule to be reflected in production and historical changes. James, you might need to keep me honest on this, but I think that the TTL for a rule change is 30 seconds. I know some other services changes to rules or filtering takes upwards of 5 minutes. But with EventBridge, I believe the TTL on a rule is 30 seconds.
Yeah, so it's very fast. So if you're using SAM or serverless framework, you'll tend to notice by the time a deployment is finished, the rule is active. So it's around 30 seconds. When it comes to historical changes, I found the best way to implement this is if you're using a build process, again, using something like serverless framework or SAM or Terraform, you can keep track of changes there. There are also some other clever things you can do to keep logging what's going on. I found that attaching a CloudWatch log to each one of my rules to log things out makes it very clear about what's happening as the application runs.
Yep. The next question is whether there's a graphical diagram that shows the rules and the events that are being set up. And this is a great question. And I think this is, so it's not a feature that we support today, being able to view this graphically. But I think it's a very cool idea and something that we should try and look to do in this service. So I will take that back to the team and talk about it. There's actually a community maintained CLI tool. If you look in GitHub, and potentially James and I could paste the link here or tweet it out later, but very simply, it's just EVB-CLI, so EventBridge CLI. It's maintained by someone out there that uses EventBridge. And it's got a particular feature which is really cool, that if you're using the schema registry, it'll allow you to run a CLI command that will allow you to select a particular schema in your registry. And then it'll go and scan through all of your rules and tell you which functions or Lambda functions or targets you have set up that are monitoring, that are matching against that particular schema of event. So it's a great way through the CLI to be able to see what subscribers you have for a particular event. But yeah, good question. There's another question here, how to express complex applications with thousands of different events and rules. So today, EventBridge has a soft limit of 300 rules per an event bus. But you can send in a request to have us increase that. And at the moment, there's a hard limit of about 2,000 rules on an event bus. We are looking to increase that limit, but today you can support about 2,000. We find for most use cases that should be plenty. And rules allow you to get very specific about the types of events that you're wanting to match against. And each rule can have up to 5 targets as well. So there's a way to kind of reuse those rules if you have multiple targets that all need the same event.
So are events not grabbed by any subscriber, do they remain available? So this is a great question, because if you have a rule where there are no targets available and the event is received and it matches the rule, it won't go anywhere. So it basically then stops at that point. So you're in complete control over what happens to events and their targets. Now, if you want to make sure that you catch absolutely everything that comes through, you can set a very, very broad rule and then route that traffic to SQS, CloudWatch, whatever else you need to do in your infrastructure. But you have complete flexibility to decide how you can handle events that otherwise wouldn't be matched. And then the next question, which important limits should
James,
I know? Yeah, sorry.
Maybe just one more point on that. I think a really cool pattern that I see a lot of customers using is setting up a broad rule like you've described that matches against all the events being sent to their event bus, and then sends those events to Kinesis Firehose, which then stores the events in S3. And once you have all of your events stored in S3, you can use something like Athena to query them. So it's a great way to kind of use events to actually give you insights and data into your business, because you can write Athena queries or use things like AWS QuickSights to build a dashboard based on those events. So I think that's a way to kind of also use that archiving of events in a helpful pattern.
Yeah. And then which important limits should I know before I start using Amazon EventBridge? So that's a great question. So all of the services we have quotas attached to them. So before you use any service, it's worth Googling what the quotas are. And the quotas are there, they consist of soft limits and hard limits. And essentially they're there to protect you when you first start using these services to make sure that your application is performing the way you want it to. So soft limits we can raise. And when you find those, you can set a support ticket and let us know and we can raise them for your use case. But always check the quotas and the documentation before you start using the service. We break down absolutely everything there.
Cool. The next question is about how well EventBridge works with multiple accounts. So this is an awesome question, and I will say that we're really excited about multi-account architectures with EventBridge, and we see a lot of opportunity to create a very healthy architecture using multiple accounts. It reduces your blast radius. It allows you to kind of separate out those accounts so that each team is using a different account. So I think that's a great architectural approach to take when building your applications. EventBridge has a particular target called a cross-account event bus. And so what that allows you to do is create a rule that routes an event from an event bus in a particular account to an event bus in another account. So what we see a lot of customers doing is they might have a team, for example, that is doing invoicing. And so they might create a rule on this shared event bus in a particular account that routes events into an event bus into their team's account. And from there, they have rules that then route that event to a particular Lambda function that creates the invoice. So I think that's a very common architecture and a very good one for customers to use. On the other side of this, you can have different accounts publishing into a central event bus that's in a single account. And you can do that by creating IAM roles in that account that are then assumed by the account that is publishing those events to that event bus. So today, the kind of answer for this is to use IAM roles to do this. I think, again, I mentioned earlier, we're doing work on the EventBridge event bus resource policies. So I would say watch the space. We're hopefully going to make this a lot easier for you to build multi-account architectures with EventBridge. I'm not allowed to say too much more on that.
Are the targets per event rule soft limits, and sometimes an event may be consumed for 5 or more services? So one of the interesting things about this is to not forget with EventBridge how you can combine it with other things. So SNS has certain capabilities, and so does SQS. And I found when I'm building applications where I want to place an event to lots of different targets, hundreds of targets potentially, I can do EventBridge to SNS. Or if I want to change the way the durability works, I can do EventBridge to SQS. So really a lot of the combinations can be very, very powerful when you start plugging it together. So I wouldn't think about the 5 targets as being something that's really a limit at all, because you can connect other services to help with the problem.
Yeah, that's a great call out. I think a lot of customers will use EventBridge to kind of route all of their events to the central event bus, but then they might need to fan those events out to a large number of subscribers, potentially sending a push notification or an email off. And so they'll often have SNS as a target on EventBridge to achieve that fan out. Another question here is, once the message is inside EventBridge, is there a 100% guarantee for delivery? And is there a similar mechanism for DLQs? So great question. Today, what happens when you send an event to EventBridge, we will respond with a 200 once we have received that event. And at that point, what we've actually done is replicated the event across availability zones. So there's a really high degree of durability of your event once you receive that 200 from calling the put events API. What then happens is, if your event matches against a rule and is sent to a particular target, there's a chance that that target might be down, or that there might be some issue with that target. So today, EventBridge will retry delivery of that event for 24 hours with exponential backoff. And what we find is that, because all of the targets of AWS of EventBridge are AWS services, we have a really high success rate in sending those events through. And so 98% of our failures occur because of incorrectly configured permissions or because of a particular resource being deleted. So in those situations where we can't deliver an event to a target, and mostly it's because of permissions or the resource not being there, what we actually do is emit a metric to CloudWatch metrics to say there was a failed invocation. Today, we don't have a way to send those events to a dead letter queue, but I would say that that's a feature that you should look out for, because it's a really good idea. And again, without saying too much, I really hope we can build that.
And the last one I see here is a good question: is what is the performance of EventBridge? So that's a broad question. So I'd say, in the experience I've had, I've been working with it really since it was launched. And the key thing about EventBridge is really the sheer scale of the product. When you look at the trillions of events that are being delivered by this product, this is a very, very large piece of engineering. So in terms of integrating it throughout all of your different applications, this is where I think its strength is. I remember working with event buses a long, long time ago, and one of the big weaknesses used to be this single point of failure issue. And really having such a robust service as EventBridge takes that away as a problem. And so really that makes it something that's much more dependable for your mission critical applications.
Yeah, maybe one more thing to say there is to talk about the latency. I think that's often something, a point that folks are interested in. So we don't publish public information on the latency, but I can tell you in US East 1, the latency is typically around 500 milliseconds. In Sao Paulo, I think that our median latency is around 300 milliseconds. And interestingly, we've recently pushed out some changes first to Sao Paulo, where the latency there in that region should be a lot lower. So I'd love to hear feedback from folks here if you're using the Sao Paulo region, what the latency you're seeing there. We're working on some improvements across the board to reduce event bridge latency. But typically, I would expect a median latency of about 500 milliseconds in most regions. And that's end-to-end latency. So from when we receive your event to when we deliver it.
And we missed a question, I'm sorry. There was a question earlier about using EventBridge for map reduce. So that's a very good question. Typically, I wouldn't necessarily choose it for that. I think it depends on the volumes you're working at and what you're trying to achieve. Using other tools for that, like Kinesis, might be a better fit, but it depends on your use case. It wouldn't be my natural first instinct. Well, Nick, what do you think about that?
Yeah, it's interesting. I think that there could be this interesting idea of sending in the kind of map data as events, and then having a bunch of consumers that pull off of that based on some key in the event. And then when they do the reduce step, they could then emit the result back onto the bus. So it's not something that I've seen, but it does seem possible and like it could be interesting. But yeah, I would say it's probably worth us having a closer look at what that architecture would look like before we give it the stamp of approval.
Yeah, it's an interesting question. And there's one that's just appeared about certifications. Does EventBridge appear in the tests? Well, I can say that although Nick is the person who runs EventBridge, and I work at AWS and know EventBridge fairly well, neither of us know anything about what's in the AWS certification test. So they don't tell us, and we might not pass the exams if we took them. We don't know. But no, seriously, it's a totally separate area. But I would hope some of the questions would be about EventBridge.
It seems like that might be any of the questions for now. I would say that any of you, if you have any other things that come up after this and want to ask us some questions, please feel free to send them through to James and I on Twitter. Our Twitter names are up on the screen here, so you should be able to reach us there. We love hearing from you. We love hearing feedback about EventBridge as you start to use it. And if you encounter any issues or things that you think we could do better, please share that with us on Twitter. It's a great way to reach out to us and get in touch. So we'd love to hear from you. And if you build things on this, tweet them. We love seeing what you're building.
Yeah, and the one thing I would add to that is that if you don't know, the way Amazon builds its applications is we get all of our ideas from our customers. So when you start using these products and finding things you want to see more of and what new features, let us know. I'm a developer advocate. I work for the product teams. Nick is a product manager. He's directly involved with the roadmap. So don't be shy. Definitely let us know what you want to see in the products, and we can maybe make it happen for you.
I think we have two last questions from Diogo Guedes. We are living difficult days. A lot of companies are searching for solutions to reduce their costs. Do you think this is a good opportunity to review workloads and adopt to serverless and event-driven architecture?
Yeah, so with this, it's a great question, because a lot of the time when we look at how customers are using instances, either on-premise workloads or EC2 instances, they're not using the full capacity of those instances. And so one of the reasons why serverless can often be very cheap compared to using an on-premise solution is because we can pack those resources on our side more clearly and get a better cost utilization out of the plant. So often when you look at workloads that can be migrated to serverless, that's one of the main reasons why there's such an enormous cost difference and why serverless can be so much cheaper. I think EventBridge can be really helpful in adopting some of the patterns that make it easier for the migration too. So if you're looking at getting things off on-premise and using strangler patterns or anything like that, working with an event-based model can really help you do that very quickly.
Okay. And the last one from Augusto Sandoval. This one. I will complete with the complete text too, okay? I would like to understand how Amazon Event Bridge delivers leverage on my architecture considering existing services for event-driven architecture such as Amazon MQ or Amazon SQS. For example, these services enable me to create a trigger to Lambda. How Event Bridge works with the existing decouple architectures using SQS and MQ, or is this another service to make it easier?
Yeah, it's a great question, and we hear that from a lot of folks. When should I use SNS? When should I use Kinesis? When should I use Kafka? When should I use MQ? It can be really confusing. I think that there's a number of different things that you will probably end up looking at in evaluating these, but I'll try and highlight some of the ones that I think often come up on why customers choose Event Bridge in certain situations over some of those other services. So I think the one that we talked a lot about was this concept of having a centralized event bus to which you send all of your events. And there's a lot of benefit in doing that. It simplifies your architecture. It makes it really easy to know that all of your events are just in the single event bus, so you don't have to go and look for topics that would figure out which topic your events are getting sent to. So there's a lot of benefit from that, and the reason that's possible with Event Bridge is because of the rule filtering. It allows you to really get specific with the types of events that you're wanting to match against. I think that the other big difference, if you look at things like Kinesis or Kafka, in those services, you typically have to have infrastructure that is polling a queue to pull events off of that queue or topic. And so again, as you're scaling up, you have to think about if you have lots of different subscribers that all want that same event, how you deal with that situation, and how you scale that infrastructure that is pulling off of those streams. So Event Bridge takes care of all of that for you. You don't have to figure out how to get the events off of the bus. Event Bridge will, using a rule and a target, ensure that the event gets delivered to that target. And I think that, again, removes the need to write a whole bunch of code and manage infrastructure that does that. The other part is the serverless aspect. So obviously things like SNS and SQS are effectively serverless. They'll scale up to as much as you can send them. But things like Kinesis and Kafka, you have to think about provisioning streams and splitting shards as you get increased traffic. Things like MQ, you have to add additional brokers. So with Event Bridge, you don't have to worry about any of that. Event Bridge takes care of all of the scaling for you. As James mentioned earlier, there's some limits on some soft limits, like I think for most larger regions, 2,400 events per second, but those are soft limits that you can get increased. And you don't have to worry about actually doing any of the scaling as you receive increased events. James, anything else you wanted to add on that, just when contrasting the different services?
No, I think it's a great answer. And, there's the combination of things, I think, where there's a lot of power as well, because when I first started looking at this, and you think about SNS and Event Bridge look very similar from the outside. When you actually look at the targets and the capabilities, they're fairly different. And then when you can plug them together, you can get some architectures that weren't possible before. So it is, like a lot of these things with AWS services, it's about really seeing how they mix together to give you complementary features that help you build applications.
Yeah, I think maybe the last point on that is that we've seen a lot of interest in the Event Bridge schema registry. I think as folks build event-driven applications, they quickly realize that you need some sort of way to keep track of all the events that you're emitting. And so the schema registry and the schema discovery feature that is built in on and kind of directly works on an event bus is a really great way to get up and running and to give you these schemas. And once you have schemas for all of your events, as you hopefully saw in that example with PyCharm, it's really easy to write code that reacts to these events and have these strongly typed objects that represent those events in your bus.
Cool.
Okay.
Guys, we have one last question here from Marcelo, asking if there is any place where we can find some public roadmap.
Yeah, so I've maybe naughtily given you a bit of a hint of some of the features that we're working on. And at the moment, we don't have a public roadmap for Event Bridge. I know there are some AWS services that do that. I think it's a really great thing to do. So I will take that back to our team and use that as an input to say that I know that all of you are very interested in what's coming down the line. So at the moment, we don't have anything public on EventBridge, but I think that's a great idea, and hopefully the hints that I gave you here gave you an indication of some of the areas we're working on.
Got it. And for sure, we know most of things cannot be disclosed, but what else can we expect? And sure, only if it can be disclosure. We cannot create any issue.
You can't ask me. You can't ask me that. I've already said too much. But I would say if you really are considering using EventBridge and there are features that you're looking for that we don't yet have, send me a DM on Twitter. My DMs are open, and I'm happy to chat to you in a slightly less formal situation there about the types of things we're working on, and it's great, always great to have ideas from you on features as well. So if there is something you're looking for specific info on, feel free to get in touch with either myself or James.
Yeah, and I would add on that as well that when it comes to all of these serverless products within the whole of the portfolio, although we don't disclose exact roadmap details, if you look at the general themes, with such incredible growth in usage in the last couple of years, with really some of the world's biggest companies using this for massive workloads, the sorts of things we're focusing on are ever better performance, ever lower cost. And so a lot of these things drive what we're thinking about all the time in terms of delivering those features. So although we don't talk about the absolute specifics, those are the general trends that are always true.
Okay. I think we finish. I will have some.
Actually, there's just one. I'm sorry, Vanzi, but the guys are really excited, sending a lot of questions. If I may, I just want to ask the last one from William Peixoto. Do I have the guarantee that every event will be delivered to the target?
Yeah, good question. So the way that works is EventBridge will retry delivery to a target for 24 hours. And we do that with exponential backoff. So I think it works out to us retrying about 1,000 times, or somewhere around 1,400 times over 24 hours. And so, the cases where that event won't get delivered is, as I said, I mentioned earlier, I think 98% of our failures that do happen, and we have a fairly low failure rate, are because of incorrectly configured permissions or a resource that is a target being deleted. So, the case that where an event might not get delivered outside of that is if one of those AWS services down for more than 24 hours, and that's pretty much unheard of. I won't say that it could never happen, but that's a very rare thing. We have really good uptime among our AWS services. So today, to answer that question as short and succinctly as possible, there isn't 100% guarantee, but we will retry events for 24 hours with exponential backoff to do that delivery.
Okay, guys. Our group needs to thank you. It's the one of the event that we have more questions in our history. It's nice. I put your Twitters here on the screen if someone wants to have more questions to you. And that's it.
Cool. Thank you so much for having us. This has been so fun. Your questions were fantastic, and we really look forward to hopefully seeing you in person next time.
Definitely.
Thank you. Definitely.
Great. Thank you, James and Nick. And also, I want to say extend our thanks to Carissa Woods for always supporting AWS communities and user groups worldwide, and also Rebecca Mesh for connecting us with you guys. So we're expecting your visit here next year here in Brazil, and we hope to send you guys feedbacks by Twitter, DMs, so we will be able to support you, to provide feedbacks about this experience shared.
Great.
Okay, thank you very much, guys.
Thank
you very much. Take care.
Cheers, everyone. Bye.
Bye.
Thank you. Bye-bye.
Ok, galera, então vocês gostaram? Foi muito legal, né? Mas não acabou o meetup, agora a gente vai chamar aqui o Diogo, porque hoje é dia de sorteio de voucher.
Oba, e. Vamos lá, Diogo. Antes do Diogo começar, eu queria sempre lembrar, like no vídeo, inscrevam-se no canal e dividam com um amiguinho. Vamos lá.
Fala, galera, tudo bom com vocês? Muito bom a apresentação, né? Ouvi em primeiro nível aí dos especialistas que manjam desse tipo de coisa. Às vezes a gente está ali preso no nosso monolítico, vivendo no nosso mundinho, mas essa questão da crise às vezes impulsiona a gente para frente, né, pô? Os nossos gestores sabendo que essa questão de serverless, arquitetura orientada a eventos aí, pode reduzir custos, por que não, né? A gente avançar com esse tipo de arquitetura na nossa empresa. Mas chega de enrolação. Fábio Gol, você está por aí? Parabéns, meu amigo, o curso é seu. Depois eu envio um e-mail para você, tá bom? Obrigado aí pela presença de todos. Valeu, galera.
Valeu, Diogo. E, pessoal, a gente vai compartilhar uns links, vai ficar na descrição do vídeo também, e nós vamos compartilhar com todo mundo que participou, vamos mandar no mailing list do grupo. O James e o Nick, eles deixaram uma série de links para vídeos do YouTube e blog e uma série de recursos relacionados ao Eventbridge.
Ok.
É isso aí. E a gente conta com o feedback de todos vocês para que a gente tenha conteúdos sempre direcionados para aquilo que a comunidade espera. Lembrando que o nosso próximo meetup vai ser em colaboração com o time do User Group do Ceara, certo? Então, fiquem de olho que a gente vai liberar lá na plataforma Meetup, link e evento para que vocês se inscrevam.
Ok. Obrigado, galera. Valeu mais esse evento. Fantástico. Foi um dos que a gente teve mais questões. Eu achei impressionante. Muito obrigado mesmo. E curtam e compartilhem nosso canal. Abração, beijão. Tchau, tchau.
Até a próxima.
Um abraço, pessoal. Tudo de bom. Valeu.
Tchau, tchau.